Hey guys, here we are given the vapor pressure of pure water and asked for the vapor pressure of water after we've mixed something into it. In this case it's salt, it could be sugar, it could be anything. Here's the deal. The vapor pressure of a mixture is equal to the vapor pressure of the solvent when it's pure times the mole fraction of the solvent. So the more of something else that we put in there, the lower the vapor pressure is going to be. The question is, how do we find the mole fraction of water? And that's simply the number of moles of water divided by the number of moles of stuff total that we have inside the solution. Alright, so how many moles of water do we have? Well, we have 375 milliliters, and it's 1 gram per milliliter. That means the number of moles of water we have is 375 grams. Don't forget to divide by the molar mass in order to convert to moles. That's my number of moles of water. We also need to figure out the total number of moles. Well, we have to account for the fact that we have some water in there. Our 375 divided by 18.02. There's the moles of water. We also need the number of moles of NaCl. In that case, 34.2 grams divided by the molecular mass of NaCl, which I believe is 58.44. But, and this is the key part of this question, when NaCl dissolves in water, it goes on to produce sodium ions and chloride ions separately. So for every NaCl we put into solution, we get 2 particles, 1 sodium atom and 1 chlorine atom, and they're completely separate now. There's water mixed in with them, but in terms of the number of particles that we have, which is what the mole fraction kind of measures, we actually have twice as many particles as this number would give us. Twice as many particles as NaCl's that we put in. So, where's my graphing calculator? Graphing calculator, what am I talking about? Alright, I'm going to crunch the top and bottom separately for you. 375 divided by 18. Apparently I have 20.81 moles of water. And I have put in 34.2 grams of salt. Oh, nuts. 34.2 grams of salt, which is 0.58 moles. But we get 2 particles for every 1 salt that we put in, so that actually adds an extra 1.17 moles. Anyways, the mole fraction from there turns out to be 20.81 divided by the sum of 20.81 and 1.17. I got it to be 0.9468. That number for the mole fraction goes here. The vapor pressure of the pure stuff was 118.1, at least in torr. Multiply that mole fraction by 118.1, and the vapor pressure of this saltwater solution I get to be 111.8 torr. But again, the key for you is to recognize that when salt dissolves, you get 2 separate particles from it. If this was sugar, you wouldn't need this 2, because sugar doesn't break into separate particles when it dissolves in water. You just got to be careful. Good luck on your own vapor pressure DLE questions.